Okay, chemistry. We are doing the notes now for limiting and excess reactants. So get out your notes that I have given you about this, and let's see how this goes. All right. So we're first going to define what a limiting reactant is. The limiting reactant is the reactant that is consumed first in a chemical reaction, limiting the amounts of products that are formed. Remember that the reactant is what we're starting with, and the products are what we end with. Okay, and then the excess reactant is the reactant that is not used up completely in a chemical reaction. So we got the limiting, that's all going to get used up, and that limits how much of the product we can make because we don't have any more to that we need to make more of the product. And the excess reactant is the one that we have extra of, and it won't get completely used up. So here's an example. In the equation C plus O2 that gives us CO2, represent this reaction with a molecule drawing. Well, if we have some carbon atoms and some oxygen atoms, okay, so look at this, oxygen molecules, I guess I should say, because remember that oxygen always, when it's by itself, it's always together because it's one of those diatomic. So what they have here, they have 5 carbon atoms and 1, 2, 3, 4, 5, 6, 7 oxygen molecules. So if we draw this, what can it make? It can only make 1, 2, 3, 4, 5 CO2 molecules. And there are 2 oxygen molecules left over in excess. So which reactant is the excess reactant? Oxygen. How do we determine the limiting and excess reactants for a chemical reaction? Well, let's look at this first. This reaction has a ratio of 1 to 1 for the carbon and oxygen. The coefficients out in front are 1. Okay, so for the 5 carbon atoms, we need 5 oxygen molecules, and that will leave 2 oxygen molecules left over. Oxygen then is the excess reactant, and since the carbon is all used up, it is the limiting reactant. It limits the amount of product that is produced. How do we determine which are the limiting and excess reactants? When we had a picture like that, it was really easy to see. And the things that we did yesterday with the sandwiches and the pictures that we drew of molecules, it's easy to see. But what if we can't draw a picture? We're going to use stoichiometry. I know it's your favorite. Using stoichiometry, the 2 reactants, remember that's what we start with, are compared to see how much of each reactant is needed. So we're going to do just like we did last week with stoichiometry, and then compare what we have and what we need. So let's try an example. Okay. All right, we'll just go here. Here is our balanced equation. Remember, you always got to start with a balanced equation. And we are going to label everything in these equations have and need. You always start with what you have and see what you need. So here is the balanced equation, and the question is, if this reaction is run with 6.25 moles of HCl and 2.75 moles of CaOH2, which substance is the limiting reactant? Which one? Okay, so they gave us moles of both of the reactants, and which one's going to get used up first, and which one will we have some left over? Because you can see here that the coefficients are 1 to 2, and this is not 1 to 2. This is not just exactly 1 to 2. So one of them is going to be more. So you're going to label each equation. We're going to start with what we have. We have 6.25 moles of HCl, and just like stoichiometry, we're going to find the number of moles of CaOH2. So we put that on the top. The moles of HCl go on the bottom because that's what we have. These numbers out in front, 1 to 2, are the coefficients from the balanced equation. And we're going to do this on your calculator, and you get 3.13 moles of CaOH2. That's what we need. If we have 6.25 moles of hydrogen chloride, we need 3.13 moles of CaOH2. Okay, now we're going to do the other equation. If we have 2.75 moles of CaOH2, that's what they gave us up in the problem. Both of these halves are what they gave us. And we're going to change the number of moles of CaOH2 to moles of HCl. So we flip these because this equation, this fraction is flipped. So 2 moles of HCl to 1 mole of CaOH2. Those come from the coefficients in the balanced equation. We would need 5.50 moles of HCl. Okay, if we have 2.7 moles of CaOH2, we need 5.5 moles of HCl. Now we're going to compare what we have and what we need. We need 3.13 moles of CaOH2. We have 2.75. We need 5.5 moles of HCl, but we have 6.25. Okay, we're going to compare what we have and what we need. Since we need 3.13 moles of CaOH2 and we only have 2.75, calcium hydroxide is the limiting reactant. We need more than we have, so it's the limiting. That means since we need 5.5 of HCl and we have more than that, that's going to be the excess. Okay, we have some left over. Since we need 5.5 moles of HCl and we have it says 6.75, but really it's 6.25, we have plenty and some will be left over. So that means the HCl, the hydrogen chloride, is the excess and the calcium hydroxide is the limiting. Okay, how much excess reactant is left over? Okay, this all right here is exactly what was on the slide before. This isn't anything new. This is just a repeat of the slide with some of those circles taken away. Okay, what we have, what we need, what we have, what we need. We figured out that HCl was the excess. CaOH2 is the limiting. How much of the excess reactant will be left over? All you do is subtract. We need 5.5, we have 6.25, so we're just going to subtract those and we will have 0.75 moles of HCl left over. That's all we're doing right here. Okay, let's try another one. If you would like to try this on your own, you can turn off the video and try it and see if you can do it. And then come back and see if you get the right answer. Okay, they tell you what you have. You have 95 grams of copper sulfide and you have 55.7 grams of oxygen gas. Which reactant is the limiting reactant? So we're going to start with what we have. We have 9.5 grams of copper sulfide. So then you're going to have to change it to moles. Remember, if you're given grams, you always change it to moles first. So we take what we have, 95.0 grams. We change it to moles. Okay, this 1 mole of copper sulfide, and we put grams on the bottom. This 95.62 comes from the periodic table. grams always come from the periodic table. And then we're going to change the moles of copper sulfide to moles of oxygen. And so this 3 to 2 are the coefficients from the balanced equation. 3 moles or 3 molecules of oxygen to 2 of copper sulfide. Okay, so that gives us moles of oxygen. But since they're telling us grams of oxygen, we're going to have to change it to grams. So we're going to get this 32 from the periodic table. You're going to look at oxygen and count up, find 2 of them. And then you're going to do this whole equation on your calculator, and you get 47.7 grams of oxygen. All right. I'm going to do the oxygen one on the whiteboard. So let's see if I can do that. No, that's not what I wanted. So let's go back to the whiteboard. And we have 55.7 grams of oxygen. That's what they gave you in the problem. Okay, you have grams, so you have to change it to moles. So you put grams on the bottom and you put moles on the top. Because remember, these have to cancel. So they have to match. Whatever you have here has to go here. And you have 1 mole. Moles always go with 1 when there's grams on the other, either on top or bottom. And grams you get from the periodic table, 32.00. You look on your periodic table, oxygen is 16, 2 16s is 32. Then we're going to do moles of oxygen to moles of copper sulfide. Because we're trying to see if we have 55.7 grams of oxygen, how many grams of copper sulfide do we need? So these numbers right here come from the balanced equation. Let me write the balanced equation up here. Okay, so we say copper sulfide has a 2 in front, so a 2 goes there. Oxygen gas has a 3 in front, so a 3 goes there. And then, because the problem is all in grams, we got to change these moles. So look at this. This cancels with that. So that means this has to go down here. So this has to be moles of copper sulfide, and this has to be grams of copper sulfide. So when we have moles to grams, the moles are 1 and the grams are from the periodic table. You're going to look up copper, you're going to look up sulfur, you're going to add them together, and you're going to get 95.62. You're going to do this whole thing on your calculator, and you're going to get 111 grams of copper sulfide is what we need. Okay, so we have this much oxygen, we need this much copper sulfide. In the problem that we already did, we have 95.0 grams of copper sulfide. And when we did that, we found out we need 47.7 grams of oxygen. This is what's important in these problems, writing have and need. I want to see the have, I want to see the need. Now you're gonna match them up. We need 47.7 grams of oxygen. we have 55.7. We need 111 grams of copper sulfide. We have 95.0. So which one is limiting and which one is excess? Okay, when you have more, so we need 111 grams of copper sulfide, and we have 95. We have plenty, okay? Or no, we don't have enough. We don't have enough of that one. So this is going to be the limiting, because we need more than we have, and this one is going to be the excess, because we have more than we need. So let's go back to the screen, see if I can do that. And let's see how, here's what we did. We have and need, and then we did this one. I did this on the whiteboard. We have 55.7 grams of oxygen. We need 111. So we compare what we have and what we need. And here's the limiting, because we need more than we have. Here's the excess, because we need less than we have. Okay, so which reactant is the limiting reactant? Copper sulfide is the limiting reactant. All right, let's look at this example. All right, what mass of barium nitrate can be formed by the reaction between 75 grams of barium carbonate and 35 grams of nitric acid? All right, so you got to stick with me with this. You have to follow me. You can't just put this video on in the background and think you're gonna absorb it. You've got to see where all the numbers come from. Okay, we're looking to see the mass of barium nitrate, which is what we're a product, what we can have in the end, this BaNO3 How much, what is the mass of that? So we're looking for grams by the reaction between 75 grams of barium carbonate, so that's this BaCO3, and 35 grams of nitric acid, which is NHO3. So that's not, we don't have this, one of these we're going to have extra of. So first of all, we have to determine the limiting reactant. Always use the limiting reactant to determine the product. Okay, so if it turns out that we're not going to use all of the nitric acid, then we're going to use the 75 grams of barium carbonate to find how much we can make, or if the other way around. So we first have to find the limiting reactant. So we're going to do just like we did on the last two. We're going to start with 75 grams of barium carbonate, okay? And we're going to change it to moles. So this 197.34 comes from the periodic table. Then we're going to change the moles of barium carbonate to moles of nitric acid. And this 2 and this 1 come from the coefficients from the balanced equation. And then we're going to take the moles of nitric acid and change it to grams of nitric acid. This 63.02 comes from the periodic table. 1 H, 1 N, 3 O's. Add those all up, you get 63.02. Do this whole equation on your calculator, and you get 47.9 grams of nitric acid is what you need. Now we're going to do the same thing with the 35 grams of nitric acid. 35 grams of nitric acid is what we have. We're going to change it to moles. So the 63.02 comes from the periodic table. This one, now we're changing the moles of nitric acid to moles of barium carbonate. The 1 and the 2 come from the coefficients of the balanced equation. Then we're going to change the moles of barium carbonate to grams of barium carbonate. So the 197.34 comes from the periodic table. Notice that you're using all the same numbers than you did up at the top. They're just all switched. Okay, you're going to do this on your calculator, and you get that you need 57.8 grams of barium carbonate. So, which is the limiting reactant? You tell me, which one? We need 47.9, we have 35. We need 54.8, we have 75. So the nitric acid is our limiting. Okay, we have less than we need. So we can't use all of our 75 grams of barium carbonate, because if we did, we would need 47.9 grams. And we don't have 47.9 grams, we only have 35. So we're gonna have extra barium carbonate in the end. So that means we're going to use our limiting reactant to determine how much product we can make. Okay, so our limiting reactant is HNO3. So now we're going to do, now we know the limiting reactant, the reactant that limits the amount of product produced. We use that reactant to determine the amount of product produced, like we did in the lessons last week. Okay, so we're going to start with 35 grams. Always use the limiting reactant to calculate the amount of product produced, because if you use the excess, we don't have enough of the limiting. So start with what we have, 35 grams of NHO3. We're going to change it to moles, because you always change everything to moles. This 63.02 comes from the periodic table. When these match, when the HNO3 over HNO3, this comes from the periodic table. Then we're going to change the moles of NHO3 to moles of barium carbonate, and this 1 and this 2 come from the coefficients of the balanced equation. And then we're going to change moles of barium carbonate to moles, this is barium nitrate. I'm sorry, I said barium carbonate. We're looking for the product now of barium nitrate. So that's why we're looking on the right side of the arrow, BaNO3, 2. So the 1 and the 2 come from the balanced equation. And then we're going to change the moles to grams, because it asked us if mass, so that means grams. So that means that this 261.35 comes from the periodic table. You do all this on your calculator, and you get 72.57 grams is how much can be formed if you have 75 grams of barium carbonate and 35 grams of nitric acid. You're not going to use all 75 grams of barium carbonate. You're going to have extra. But we had to find the limiting reactant to see which one of those numbers we were going to use. Okay, and how much excess reactant do we have left? We're going to take the 75, which is what we have, subtract off what we need, which is the 54.8, and we're going to have an extra 20.2 grams of barium carbonate that we're not even going to use for this chemical reaction. Okay, tips for identifying problems that you need to determine the limiting reactant first. When a problem gives amounts for both reactants, you need to determine the limiting reactant first, then calculate the amount produced using the limiting reactant. Last week, when we did the basic stoichiometry problems, you only had an amount of one reactant. You weren't given both of them. So when a problem says that one of the reactant is in excess, assume the other is the limiting, and then use the limiting to calculate the amount of product. Okay, let's try another one. This says partner challenge. What volume of hydrogen at STP is produced from the reaction of 55 grams of magnesium and 75 grams of hydrochloric acid. All right, I'm going to go back to the whiteboard. Like doing that. All right, we're going to try it on here. You ready? Let's look at the equation. We got magnesium plus 2HCl, and that gives us MgCl2 plus H2. Okay, that's balanced. Remember, you always have to start with a balanced. What volume of hydrogen at STP is produced from the reaction of 55.5 grams of magnesium and 75.0 grams of HCl? So what is it asking us? It's asking us this. How much of this we need? But it gives us both an amount of magnesium and an amount of HCl. So we have to see which one is the limiting reactant. So let's start with what we have. We have 55.5 grams of magnesium. So the first thing we always do, if you're given grams, is change it to moles. So that means that grams of magnesium has to go on the bottom. And we have to, when these match, magnesium and magnesium, a 1 goes here, and we look up the grams from the periodic table, and we get 24.31. All right, then we put moles of magnesium on the bottom and moles of HCl on top, because that's what we're comparing. We're comparing magnesium and hydrochloric acid. That's what we're comparing. So these numbers come from the balanced equation. There's a 2 in front of hydrochloric acid and a 1 in front of magnesium. There's nothing in front of magnesium, so we know it's a 1. Then, because we're given grams up here, we've got to change our moles of hydrochloric acid to 2 grams. Okay, and since these match, a 1 goes here, and these grams come from the periodic table, which is 36.46 grams. You're going to do all of this on your calculator, and you're going to get 166 grams of HCl. That's what we need. So we got what we have what we need. Now we got to do the other one. We have a half of 75.0 grams. We got to change it to moles. Since they match, we find this from the periodic table, which is 36.46. Then we put moles of HCl down here, and we're going to have moles of magnesium because that's what we're comparing up here. Since these are both moles of different things, we use numbers from the balanced equation, which is a 1 and a 2. And then we have to change these moles to grams. So we're going to use this number from the periodic table, which is 24.31. Okay, look at grams, grams, moles of HCl, moles of HCl, moles of magnesium, moles of magnesium. They always have to match. Okay, that's not that difficult. Whatever you have here goes down here. Whatever you have here goes down here. Whatever you have here goes down here. It always is the same. Do this on your calculator, and you get 25.0 grams of magnesium. That's what we need. Now we're going to compare. We have 55. We need 25. We need 25. We have 55. Do we have enough? Yes. We need 166. We only have 75. Do we have enough? No. So that tells us that this is our limiting. HCl is our limiting reactant. We don't have enough of that to use all of our 55.5 grams of magnesium. So we're going to have extra magnesium. We're going to use all of our 75 grams. So that's what we're going to use to find out how much hydrogen, remember that was the original problem, how much hydrogen we have. So let's look at the next step because we're not done yet. All we did was find the limiting reactant. Put our equation back here. So since we found that HCl was our limiting, that's what we're going to start with. 75.0 grams. Grams HCl, grams HCl. What do you always do when you're given grams? You change it to moles. So we're changing our grams of HCl to moles of HCl. A 1 goes there. This number comes from the periodic table. And moles of HCl, moles of HCl. And what are we looking for? Hydrogen. So that goes there. And these numbers come from the balanced equation. There's a 1 there, and there's a 2 here. Remember, if there's no number, it means there's a 1. And then what are we looking for? This would tell us this, if we did this equation that's on the whiteboard right now, that would tell us how many moles of hydrogen we could make. But it's asking us, what is the volume? Volume is liters. So we want liters of H2. And we know that moles of H2 have to go down here because it has to match this. So remember, for liters, that number is 22.4. That's from last time. Now you can do this all on your calculator and you should get 23.0 liters of H2 at STP. And that's your answer. Okay? That is how you do these problems. Let's see if we can look at the screen again and see how we did. Okay, here it is. We have 55.5 grams of magnesium and we need 166 of hydrochloric acid. And we had 75, we need 25 of magnesium. So we compare our needs and our haves. And our limiting is the HCl and our excess is magnesium. Always use the limiting to calculate the amount of product produced. The question asked us for something about the product. So we had to find the limiting. So we're going to take our limiting reactant, which is the 75 grams of HCl, and find how many liters of hydrogen. Okay, the next one is really complicated, so stick with me. Silver nitrate and sodium phosphate are reacted. 235 grams of silver nitrate and 179 grams of sodium phosphate are used for the reaction. How many grams of silver phosphate are produced in this double replacement reaction? Identify the limiting reactant and determine the amount of excess reactant that would be left over. All right, so the first thing you would have to do in this is to actually write the equation, silver nitrate and sodium phosphate. So get out your polyatomic ion chart. Silver and nitrate, they have the same charge, so it's AgNO3. Sodium phosphate, we got sodium and phosphate. Phosphate has -3, sodium has +1, so we get Na3PO4, okay? Then it says it's a double replacement reaction. That means the silver has to go with the phosphate and the sodium has to go with the nitrate. So we'd have to put silver with phosphate, sodium with nitrate, and then we have to balance it. So there's a lot of things you have to do before you even start this problem. Then you do your halves and your need, and yes, your halves. So they told us that we have 235 grams of silver nitrate. So we're going to change it to moles. So 169.88 comes from the periodic table. We change that to moles of sodium phosphate. The 1 and the 3 come from the balanced equation. We're going to change moles of sodium phosphate to grams of sodium phosphate. So the 163.94 comes from the periodic table. Do all this on your calculator and you get 75.59 grams. Same thing with what we're given for sodium phosphate. 197 is what we're given. We change it to moles. The 163.94 comes from the periodic table. The 3 and the 1 come from your balanced equation. And then the 169.88 from the periodic table to change it back to grams. Let's compare what we have and what we need. We need 612.4 grams of silver nitrate, and we have 235. That obviously is going to be limiting. We need a lot more than we have. Okay, that's all we need here is the limiting. So the silver nitrate is the limiting, and we're going to use that to find out how many grams of silver phosphate is the Ag3PO4 is produced. So we're going to start with our limiting, which is the 235, change it to moles. So the 169.88 comes from the periodic table. The 1 and the 3 comes from the balanced equation. Change it back to grams. The 418.58 comes from the periodic table. And we get 193 grams of silver phosphate are produced in this double replacement reaction. Identify the limiting reactant and determine the amount of excess reactant that will be left over. How do we find the excess reactant? Well, if silver nitrate is the limiting, sodium phosphate must be the excess. So we're going to subtract. We need 75.59, and we have 197. So we're going to subtract those. 197 minus 75.59, and we get 121.4 grams remaining of sodium phosphate. We didn't even use. That's the amount that we didn't even use. All right, so that is how we do limiting and the limiting an excess reactant. So now you're going to have a little chance to do some on your own.